Hello viewers, in today's class we are going to learn about the concept of stationary points in maxima and minima, right? So let us first take the definition of stationary points. So the definition of stationary points, uh, it goes like this: a stationary point is a point at which the derivative of a function is 0, right? So let us take a function, say y is equal to f of x, right? Now we'll find the derivative of this function, and it is given by dy over dx is equal to f prime of x, right? Now in order to find out the stationary point, we should equate the derivative equal to 0, right? So we have dy over dx is equal to 0, or f prime of x is equal to 0, right? Now if we solve this equation, f prime of x is equal to 0, then the different values of x which are obtained by solving this equation are known as stationary points, right? So let us take an example. Now here we have this quadratic function f of x is equal to 3x square plus 6x plus 8, where x belongs to R. Now here we wish to find out the stationary point, right? So let us differentiate it. So f prime of x, that is the derivative of f of x, is 6x plus 6, right? Now the stationary points are obtained by solving this equation, right? F prime of x is equal to 0, so we have 6x plus 6 is equal to 0, 6x is equal to minus 6, and x is equal to minus 1, right? So x is equal to minus 1 is the stationary point for this quadratic function, right? Now let us take one more example. Here we have the function f of x is equal to x cube minus 3x. Now this is a cubic function, so in order to find out the stationary points, let us differentiate it. So f prime of x is equal to 3x square minus 3, right? And for stationary points, the derivative must be equal to 0, right? So 3x square minus 3 is equal to 0. So if we solve it, then we have this equation, then x square minus 1 is equal to 0, and x square is equal to 1. So x is equal to plus minus 1. So here in this case, the stationary points are x equal to 1 and minus 1, right? Now let us take one more problem. Here we are given this function f of x is equal to x minus 5 raised to 4. Now let us differentiate it. So f prime of x is equal to 4 times x minus 5 raised to 3, right? And for stationary points, f prime of x should be equal to 0. So we have 4 times x minus 5 raised to 3 is equal to 0, and if we solve this equation, then we see that the value of x is equal to 5, right? So here the stationary point is x equal to 5. Now let us take the geometric meaning of the concept of stationary points, right? So graphically, the stationary points corresponds to the points on the graph of f of x where the tangent to the curve is a horizontal line, right? For example, let us take the graph of say y is equal to f of x is equal to sin x, right? Now sin x is a trigonometric function, and if we plot the graph of sin of x, then we get a graph like this, and we have a graph like this, right? So here we have 0, here we have pi, and here we have 3 pi by 2, and here we have 2 pi, right? So this point is 2 pi, and here we have plus 1, and here we have minus 1, right? So now let us see the geometric meaning of stationary point. Now if we differentiate this function, so we get f prime of x is equal to cos x, because the derivative of sin x is cosine x. Now to obtain the stationary points, the derivative should be equal to 0, so it means cos x is equal to 0. So it means we have to find those values of x for which cos of x is equal to 0, right? So if we solve this equation cos x equal to 0, then we get x is equal to pi by 2. The odd multiples of pi by 2, then we have 3 pi by 2, and so on, right? So here we see that at this point, right, at this point, see, this point is pi by 2, right, and this point is 3 pi by 2, and if we draw the tangent at this point, right, then this tangent is parallel to x-axis. Similarly, this tangent at x equal to 3 pi by 2 is parallel to the x-axis. So what does it mean? It means that for stationary points the derivative is 0. And what is derivative? Derivative represents the slope of tangent, right? The slope of tangent. So when dy over dx is 0, it means the slope is 0. So when slope is 0, slope is denoted by the letter m, and when the slope is 0, it means the tangent is parallel to, right? The tangent is parallel to x-axis. So if we consider the trigonometric function sin x, the derivative is cos x. For stationary points, we have cos x equal to 0, and here I have written only two solutions, x equal to pi by 2 and x equal to 3 pi by 2. There will be more solutions, and at x equal to pi by 2, this is the tangent, right? And this tangent is parallel to x-axis, and at x equal to 3 pi by 2, the tangent is again parallel to x-axis, right? So at stationary points, the tangent is parallel to x-axis, or in other words, the slope of the tangent is equal to 0. Now let us consider the graph of a function, right? Suppose we have the graph of a function like this, right? Now here we see that at these points, right, at these points the derivative is equal to 0, right? Because if we consider this as x-axis and this as y-axis, and if we draw the tangents at these points, right, at these points, say this is point A, this is point B, and this is point C, right? So if this is the graph of a function, and at these points A, B, and C, the tangent is parallel to x-axis. So A, B, and C are known as the stationary points, because at these points the derivative is equal to 0, right? So if this is the point A, this is the point B, and say this is the point C, then x is equal to A, x is equal to B, and x is equal to C are known as the stationary points, right? Now let us consider one more problem. Here we have this function f of x is equal to sine 2x, and x lies between 0 and pi, and we have to find out the stationary points in this interval, right, where x belongs to 0 to pi, right? So what we will do, we'll differentiate this function. So f prime of x is equal to 2 cos 2x, right? Now for stationary points, the derivative should be equal to 0. So we have 2 cos 2x is equal to 0. So it means cos 2x is equal to 0, and now we have to solve this equation in order to find out the stationary points. So cos 2x is equal to 0 whenever this 2x is an odd multiple of pi by 2. It means 2x can be given as 2n plus 1 times pi by 2, where n is some integer, right? So when n is equal to 0, then we see that 2x is equal to pi by 2, and it gives x is equal to pi by 4, right? Now when n is equal to say 1, 2x is equal to 3 pi by 2, and this is given as x equal to 3 pi by 4, right? Now when n is equal to say 2, then 2x is equal to 2 to the 4 plus 1 5, so this is 5 pi by 2, and it is x equal to 5 pi by 4, right? Now we see that x equal to pi by 4 and 3 pi by 4. Now these 2 points lie in this interval, or in other words, these 2 points fall within this given interval. So pi by 4 and 3 pi by 4 belong to 0 to pi, right? And this 5 pi by 4, it does not belong to 0 to pi. So we exclude this point and will take only these 2 points, right? So the stationary points for this function in this interval are pi by 4 and 3 pi by 4.